Okay, so 2.5, literal equations and formulas. So this lesson is going to have us be introduced to equations that have more than one variable in them. So in example 1, we have a situation where you're ordering pizzas and sandwiches, and you have a budget of $80, so you can't spend any more than $80. This equation 2x plus 5y, where x is the number of pizzas, so I'm going to say x equals pizzas, and y is the number of sandwiches, so I'll say y equals sandwiches, models this situation. And I'm asking how many sandwiches can you buy if you buy 3 pizzas and if you buy 6 pizzas. So this equation has two different variables, one that stands for pizzas, one that stands for sandwiches. So if I know that I bought 3 pizzas, I can rewrite the equation this way. I'm going to write 2 times 3, because I know the value of x is 3. The number of pizzas is 3, plus 5y equals 80. So to solve this equation, I've first got to simplify the left-hand side, and then I use the same steps we had learned in previous lessons to solve for y. So I would subtract 6 from both sides. 5y equals 74. And I finish by dividing both sides by 5. That ends up being 14.8. Now, that's a correct solution to this equation, but in this context, if I buy 3 pizzas, that means I can buy 14 sandwiches. And the reason I didn't round that up is because I have a budget. I can't go over that budget. So if I bought 15 sandwiches, I'd be over my budget. So it's not just about rounding, it's about thinking about an answer that makes sense, meaning an answer that fits the context of this problem. So, moving to example 2, rewriting equations that only have variables. In this example, we are solving for x. So I'm going to first rewrite my equation. Negative t equals r plus px. So the fact that I'm solving this equation for x means I have to isolate x, which means I have to eliminate r from that side of the equation, and I need to eliminate p from that side of the equation. So my first step to isolating x is going to be to subtract r from both sides. So that eliminates r. Now it's worth noting that negative t and negative r, those are not like terms. So I do not combine them. I leave them as negative t minus r equals px. So the way I finish solving this equation is I divide both sides by p. So I divide this side by p, and I divide this entire other side by p. So my final solution is just going to be x equals this entire expression. There is no way for us to simplify that expression any further. We are just solving for x. It means we are isolating x. If there are no like terms, we don't combine like terms. We just leave that expression as is. So I'd like you to try example or guided practice 2 on your own. Pause the video, resume it when you're ready to check your answer. All right, so moving to the next examples, there's a lot of formulas out there, all right? There are formulas for perimeter and area. There are formulas for distance. So these are some of the common formulas. Now, most of these are geometry formulas. Distance traveled is more of a formula you're going to see in science classes. Now, what we're going to do is we're going to reference these formulas. You do not need to memorize these formulas. You just need to be able to read a situation, decide which formula is appropriate, substitute the right values, and then solve for the value you're trying to look for. So in example 3, we are rewriting a geometric formula, and you're given this statement. What is the radius of a circle with a circumference of 64 feet? So the equation I'm going to use is circumference. C equals 2 times pi times the radius. So in this equation, there's a value I know, there's a value I don't know. I know the value for circumference, I don't know the value for radius. So the value for circumference is 64. So I rewrite this equation as 64 equals 2 times pi times the radius. I still don't know the radius. I need to solve this equation now for the radius. So the way I'd go about doing that is I would eliminate pi, and I would eliminate 2 from that side of the equation. So first I'm going to eliminate 2. I divide both sides by 2. So this becomes, and I'm going to run out of room, 32 equals pi times the radius. I would finish solving this by dividing both sides by pi. So you're going to want a calculator to do that. This means r is roughly 32 divided by pi, rounded to the nearest tenth, would be 10.2 feet. And it's important that you include feet in your answer. So rounding to the nearest tenth when we're confronted with decimals. So it's understanding what variables to substitute, which variable you're solving for, and then using the proper units and rounding to the proper decimal in the end. So moving ahead to the guided practice for number 3. You can pause the video, work through this, and then check your answer when you're ready. But the area formula you can use for triangle, I'm going to give you kind of a different room from the table. Area for a triangle can be written as base times height divided by 2. You are looking for the height, you are given the area, and the base of that triangle. So take a minute, solve this for height, check your answer with me when you're ready. Okay, so moving to the final example, rewriting a formula. It says the monarch butterfly is the only butterfly that migrates annually north and south. The distance that a particular group of monarch butterflies is about, or that they travel, is about 1,700 miles. It takes a typical butterfly 120 days to travel one way. What is the average rate at which a butterfly travels in miles per day? So in this example, we are going to use the distance formula. Distance equals rate times time. The distance something travels. We are given a few of those values. We're given that the distance the butterflies travel is 1,700 feet. We are given that the time it takes them to travel that distance is 120 days. We have to solve for the rate. So I'm going to substitute these values into the equation and then solve the equation. So d is 1,700. So my equation is going to look like 1,700 equals the rate times 120. So I'm solving for rate. To solve for rate, I have to eliminate 120. That means I divide both sides by 120. So the rate the butterflies travel at is going to be a decimal. We're going to round it to the nearest whole mile per day. So to solve that, I'm going to take 1,700 divided by 120. It's about 14.166 repeating. So the distance they travel per day, rounded to the nearest whole mile per day, is 14. 14 miles per day, miles over day as my units. And that is my solution to that equation. So last guided practice is number 4. It's the same problem, just with a different situation. Okay, so now you should have enough to go off of in order to complete the practice and the checkpoint. Make sure you're paying attention to the problems I want you to do on the practice, because you won't be doing every single problem. You're only going to be doing problems I select. So make sure you're reading the directions on the post for practice in Classroom, and make sure you're answering all the questions in the checkpoint and submitting it so that you have done the requirements you need to go on to the quiz that we're going to take. So our next quiz will be next class. We will review for the first half of class before we take that quiz.